Good morning, all. So today we'll be discussing on Yang and Netconf, and also we'll start from the place where we left last time. So last time we were able to create NCS NetSim directory and the devices, and we onboarded the devices, and NSO installation and everything was ready. So for today, we will talk a bit on what is Netconf, what is Yang, and then we will create a service package. And we'll continue to evolve more in terms of more complex Yang statements, more complex, or I would say more advanced Yang structures and all. So we'll continue doing that. So here we go. So first of all, I'll talk about the transaction. So NSO itself works on transactions. So when I say NSO works on transaction, it's like every configuration or every action within the NSO is considered to be a transaction. Let me just check this why it's not working properly. Just one sec. Stop share, and we will try to share again. Airplay off, airplay on, and बताइए. हाँ बिल्कुल होंगी. So there is okay, I'll share one document which has most of the commands. Okay, बिल्कुल. You can keep noting down the commands while we discuss this, and I'll also get you this one a document. Yes. Yes. So at least once in a week you should practice on what we discuss, and then only you will get to know.
डिस्कस किया था ना जब हम ऐसा किसी डिवाइस को लॉगिन करना था तो मतलब वहां तक तो हमारी डिवाइस हमने क्रिएट कर दी बट ऑनबोर्डिंग प्रोसेस लाइक जैसे हम एनएसओ की जो यूआई है जो 8080 वाला उसको देखेंगे तो वहां पे कब दिखेगा.
ओके, सो टुडे वी विल डू दैट. हम करेंगे उसको. ठीक है. Coming back to the transaction. So transaction nature can be defined by 4 properties. So ACID we call it. So atomicity, consistency, independence, and durability. So atomicity means transactions are indivisible, means it is a unique transaction in itself. You cannot further divide it into sub transactions. Okay, so the minimum unit of an action within NSO is called a transaction. So it should be atomic in nature. Then consistency is like transactions are all at once. No internal order inside a transaction. It is set of changes, not a sequence. So the transaction is considered to be a set of changes. It's not in a sequence. It is a set of changes. Implies that create A, create B, create B, create A are identical. So that simply means that if you are reversing the order or changing the sequence, the end objective is still the same because it's not in a sequence. Okay, the system behaving differently with respect to sequence are not transactionals. Then independence means parallel transactions do not interfere with each other. So if you are doing multiple transactions simultaneously, so that doesn't impact one transaction doesn't impact other. So they can still go in parallel, and transactions appear to happen always in sequence. So if you will go with the time stamping thing, then you would still see that maybe they are happening one after the other, but they are not interfering with each other. And of course, the durability is the persistence configuration, even in case of failover, failure, restart, etc. So that implies that the transaction, whatever changes they are doing, are persistent in nature. So persistent means even if there's a reload, even if there's a restart, even if there is a failover, the changes which the transaction has done remain consistent, remains there. It's not like RAM that there is something in the memory and you restart the computer and it's gone. So that doesn't happen in case of transaction. So it's durable. So transaction order independence. So here I'm taking example of two transactions, transaction A and transaction B. So transaction A is to add an interface Ethernet 5 and add a route with some IP address over interface Ethernet 5. So this is the transaction A, and transaction B is again add another route over same interface Ethernet 5 and add in interface Ethernet 5. So it's the order of transaction which is changed. So first we are adding a Ethernet and then adding the route in transaction A, and transaction B we are adding the route first and then adding the interface. So transaction A and transaction B, they are still the same. It's not that we will have different outcome. So this is much more evident when you do the NSO BPA work, where you would see that in the SRDs, you will see the examples which they have given, or the JSON payload which they have given, that might have the actions in a different order, and when you do it from your code, the order of the actions are different, but still it is the same. I think I was discussing with Riaz last time, or with yourself, Shirish, or yourself. You were I was shown a list of actions in JSON format, and the same was there in SRD, and SRD sequence was much different from the sequence that was for MACsec. I guess, yes, it was MACsec, but still it is the same. So that's what we are trying to explain here, that configuration transaction are decoupled from their sequential execution, and obviously the order matters in the execution, but it is not the manager's concern in a transactional system. So the order would still matter while executing it, because NSO will know that an interface has to be created first and then only you can add the route. But whatever actions you have put in whatever order, that doesn't change your transaction, that doesn't fail your transaction.
How NSO will decide like whether this particular?
So that is the fast map. So that is the algorithm which NSO has. It decides that how to deal with the transaction. Fast map does it. So configuration, backup, and restore. So backup is reading the configuration, and manager does not need to know which element are configurations. Save result to a file. So it could be a human readable XML file. Use diff and other XML processing tools. Edit file if desired. So that is the backup. Means you are taking a backup of all your configurations, all your transactions which you have executed on NSO. And restore is to send the saved configuration. No need to sort data. All or nothing semantics. No PDU size limit. So NSO, what it does is it keeps your transactions, whatever you're transacting, it keeps it in an XML kind of file as a backup. And if you want to restore, you can just run that file. So that forms your payload, and it's passed as an argument in an API, and the restore happens. So in NSO, I'll show you, once we create a service, we'll kind of execute several service creations, and we will have the restore files created in a directory in NSO, which we can open. We can see it's a human readable XML file, and we can use them to restore. Means whatever changes we have done, we can undo them.
So I think NSO also maintains the save points.
Yes,
like,
it does.
The position or this the last configuration.
Yes. So for every transaction you do, there is a rollback available for that transaction. So you can roll back, even you can give tags to the rollback, that this is the rollback point where you want to go, and you can roll it back. So that is very much possible. So a little bit on Netconf. So Netconf we'll not cover in detail, but just to give an example on what Netconf is. So Netconf is your protocol for network management, the next generation protocol for network management, and this is what we intend that every device should be able to use in order to get configured. So this is more of configuration management stuff. So it is like diameter protocol which does version negotiation. So the version of netconf running on your controller, which is NSO, and the version on the device should be similar or compatible. So similar means if it is same, it's well and good. It could be Arvind called. Hey Arvind. Yes, Arvind. Sorry. So we were talking about Netconf. So Netconf is diameter kind of protocol which does version negotiation, capability negotiation. So capability negotiation is more of what all features you have, what all features I have. Do we share similar capabilities? Will I be able to, if I push some configuration, is it, are you capable of handling that configuration? And also that is more of capability negotiation. Then a supported subset of capabilities used, extensions go in separate XML namespaces, which make it easier to build backward compatible management. So there are two DBs in Netconf. So this is an example of a Netconf, I would say, payload, which can be sent in order to configure the device. So if we do not have a SSH or a telnet NED available for the device, and if the device supports netconf, so this is the kind of payload we can directly send to the device to have a netconf negotiation and do the configuration. So netconf configuration data stores are like this. So startup, running, candidate, and the other files in URL. So as I mentioned that there's a candidate DB. So whenever there is a new configuration which you push, so it gets into the candidate DB and it is parsed there to figure out if the configuration is fine or not. And then once it is fine, then it goes into the running DB. Sorry? Not sharing on this. Oh, is it? Sorry, let me check. Share. No, but I'm sharing on Zoom. It says stop share. Shall I stop share and start share again? Let me do that. Share. Share. Is it visible now? Yes. Okay. Okay. So this is a Netconf example. So you are preparing the candidate configuration here, and you get an acknowledgement receipt. It's just like a REST API kind of, or RPC API, that you create the payload for the candidate configuration. Like this is an interface configuration for creating the interface, creating the IP v4 address, and the MAC address. So the one highlighted in green, that is the configuration you are pushing. And once that is done, so you get an OK message. You can disconnect the audio. So this is another Netconf example where you're validating the configuration. It's like iOS XR commits. So in iOS XR, what happens is you configure the equipment, and then you have to say commit. And when you hit commit, then what happens is all the configuration gets validated, whether it is correct, whether this can be done or not done. And after that it is committed, or else you will have some errors popping in, that your configuration was wrong, or you have to redo it, you have to do it again, or something like that. So that's what happens in iOS XR. And similar stuff is a similar methodology is adopted by Netconf, that you do the configuration, it checks, and if there are any issues, it will let you know, or else it will permanently activate the configuration. So some of the Netconf use cases. So if you want to do some network-wide transactions, or you want to apply and test a configuration, or testing and rejecting a configuration, rollbacks when device goes down, or transactions requiring all device to be up, or backlogging transactions, or synchronization. These are some of the use cases for Netconf. And of course, the configuration means most of these use cases are related to configuring the devices. So if the devices support Netconf, that is the way we should handle the device. Means again, it's more of futuristic stuff, because right now I think in most of the projects you are using the CLI nets, which SSH on the device and do the configuration. So coming back to our Yang stuff, it would be more of interesting stuff in terms of hands-on, because we have already yeah, go ahead. Southbound, correct.
That is a layer between like device.
Yes.
And like NSO net.
Yes, yes, yes.
Basically, communication जो होता है like net और device के बीच में होता है.
Net और device के बीच में होता है, correct. So no, so wait. So net can be either a Netconf net or a CLI net. So if it is CLI net, तो net और device के बीच में configuration SSH के through होगा, और normal CLI के through होगा. जो device का जब आप conft करके device पे जाते हो और in configuration interface ये वो लिखते हो, तो it is similar for a CLI net. For Netconf net जो मैंने आपको दिखाया, so it will prepare the payload in XML and it can push it to the device. So device will also understand XML kind of protocol. So that is वो Netconf खुद device से negotiate कर लेगा. हाँ, device Netconf support करता है नहीं करता, ये पक्का होना चाहिए. Or then you will use a Netconf net. So while onboarding the nets, there is an option whether it's a CLI net or it's a Netconf net. So you have to select there if it is a Netconf net or CLI. तो हम अभी तक ज़्यादातर nets जो use कर रहे हैं वो CLI nets है, ठीक है. Netconf net को use करने का good part is that your means overall code reduces a lot, because whatever modeling you are doing in Yang and whatever device templates you have in XML, Netconf is very similar to to that one. So you are using almost similar XML templates to push it towards the device. While you do the CLI, so you are again converting that XML and Yang based modeling which you have done into the device CLI through the net, and then you are pushing it to the device. So means the end objective is to go as near as your model as possible. Okay. So I'll quickly go with some of the Yang model configurations. Again, we'll continue advanced cases of Yang in our future lectures. But today we will only discuss on some 2-3 typical Yang model, I would say, properties and structures, so that we can use them to create our first Yang model today. Okay. So the Yang model describes everything there is to configure, monitor, admin action, notification for each device type, version similar to MIBs. So just like MIB used to be there in SNMP, so it's a similar modeling for the device configurations in Yang. And here I'm showing different devices like vendor A device, vendor B device, vendor W device, and there could be different device model types. And if they're supporting Netconf, fine. If not supporting Netconf, so instead of Netconf, it will be a NED layer, and on top of that, it will be Yang model. So Yang characteristics, again, designed for readability, uses UTF-8 encoding to support international character set. Simplicity enables fast service model development. And today we will actually see how fast we can develop a service model. And modularity and hierarchy enable reuse of code. So this is a Yang model hierarchy. It's not visible. Just one sec. Okay, it came in. Okay, so this is an example Yang model. So the arrows are showing different kind of imports and includes. So you can see serious.yang. So module serious namespace something. So that is the model, and you are importing that one into acme.yang. So you are saying module acme namespace A and import serious. So while you're importing, so you're importing the whole of, so it is like any programming language where you have some classes, you have some structures made in somewhere else, and you can import the complete library or class in your code. You can refer that, and once you have imported it, then whatever functions are defined within that class, you can make use of those functions in your code. So similar stuff happens for Yang. Whatever you import, you can make use of that. Then there is your include. So include is again similar stuff, but there is means the similar difference means the same difference as it happens in programming language between import and include. The similar difference happens here for the Yang models also. So imported fragments are just referenced, means it's not that the complete thing will get into your code, but it will just be referenced, used to group reusable definitions that can be reused by many other modules similar to libraries in programming languages. And include is like useful to split large modules into smaller, more manageable files. Some modules can never be included in any other module, and module and submodules share the same namespaces. Okay, this I think should be very obvious for most of you. Yes. So namespace in Yang is like a reference term. So you give a name to every module. So namespace is like if you are giving a name like com dot something slash module one. So that is the namespace. That is the name of module one. And then if you are creating a module one slash something else, then that becomes a sub module. So it's the namespace. Yes. So we will, once we create the Yang model, we'll see the namespace. So yeah, go ahead. Any other module. Like if because like if we are creating some module, like if we are creating some common things. Yes. So I think like we can use it into the multiple. So you have to include the module itself, not just the submodule. Okay. That's what it says. It's like importing the module. Yes, importing the module. Some module. We have to import the module. Yes. And then only we can. Yes. And this is a sample Yang module structure. So here you can see module name is Acme, and we use this curly braces to start and end any of the piece of code or a segment within the Yang module. Then we have defined the namespace as http acme.example.com/module. Then prefix is another reference point. So within the code, if you want to refer this module, so Acme is the prefix name, so you can refer with the prefix name instead of writing the whole thing. You can just say import Acme, or so that one will be usable. Then organization is something which is a comment kind of thing for the developer and for the others to understand that this is for Acme Inc. Then description is again a comment, that module describing the Acme products. Then revision, all these things are mainly tag things, and they are there just for giving information. And revision is the date when this module was last revised, and there is some description that it was an initial revision. So these are all best practices of coding the Yang modules, that you should keep the revision history, and also that anybody who refers to this Yang model should be able to see what's happening there. Saying something, just one sec.
Sir, which of these fields are required, which are mandatory to? Like,
okay, so all these fields which are more of informative in nature, they are not required. Keep it, please assign. So your module, first one, module Acme, that one is very much required. Namespace is very much required. Prefix is required. Organization, description, revision, this is something which you can skip if you want, or means it's a good thing to have it. But even if you skip, then it will not hamper or improvise your means anyways diminish the usability of your module. Then import is again the one which we saw in the last slide. So import IETF Yang types, so prefix Yang. So this is where we are using this is how we are using the prefix. So IETF Yang types are defined in prefix Yang. So in a module called Yang. So while we are importing this, we will be able to use all the data structures or data types which are already defined in this module Yang. Then include Acme system. So this is another module which we are including here. Then type def is we are defining a type percentage dash type. So it is just like we define a data structure. So it's in similar way we are defining a data structure, type definition, and then we are giving the reference that what this type definition is. So it is a u integer 8 data type, and the range starts from 1 to 100. So now if we put something with the type percentage dash type, so this is the type. It will be a uint with range from 1 to 100. Now next we are doing some grouping. So grouping is again a Yang module way of grouping data. So if data is the grouping name, and we are creating leaf. So leaf is again a data type in Yang. So Yang is always considered as tree, and leaf is the atomic one small I would say container which will contain some data. So leaf could be either a type integer or type string or type leaf ref. There could be any data type assigned to the leaf. Leaf is the smallest, I would say, place in Yang model where you are defining variable or you're doing something with the values. So leaf is IPv4 address, type inet IPv4 address. So this type inet colon IPv4 address, why you are able to use it? Because you have imported something at the top, IETF Yang types. Okay, so that one was defined there, and that is why you are able to use it here.
Sir, if I change the name ACME, prefix ACME to ACME1,
you can do that.
Then like I'm importing this module to some other module. Then
you should use, so prefix also you change it to ACME1, and then you can import with the ACME1 name.
So we have to change the module ACME also to 1.
So wait, so if you want to import it somewhere else, then whatever is the prefix name you are assigning, you will import from that name. So agar you can keep ACME here, and if you want to import it with the name ACME1, then you change the prefix to ACME1. So you can refer it from somewhere else. Or for standard purposes, we keep the module name and prefix name same, because otherwise there could be a confusion within the developers also that we imported this, but the module is this, and maybe they will not look at the prefix. So that is the intent. It's not mandatory. It's not. So you are standardizing the configuration. अभी दिखाऊंगा आपको कि हम एक L2 VPN बनाएंगे. So L2 VPN का configuration 4-6 लाइन का रहता है, और अलग अलग डिवाइस पे अलग अलग टाइप ऑफ डिवाइस पे अलग अलग तरीके का होता है. But the basic ingredients for L2 VPN remain same regardless of device. So we create a model, and then we forget about the syntax.
बेसिकली मतलब अगर जैसे अपना जैसे वेब प्रोग्रामिंग के बेस पे सोचे, मतलब लाइक डीबी पे इंफॉर्मेशन हमारी सेव होती है, लाइक तो यहाँ पे वो पर्पस ये सर्व कर रहा है लाइक.
यस, सो ये कुकी कटर बना रहा है. ये आपका जो खांचा की बात की थी ना हमने लास्ट टाइम आल्सो, सो दिस क्रिएट्स अ खांचा. सो वंस वी क्रिएट द L2 VPN मॉडल, मैं उसके बाद आपसे फिर से पूछूंगा कि अब आप मुझे बताओ, एंड आई एम श्योर यू विल बी एबल टू टेल कि इसने क्या सॉल्व किया. ठीक है,
जैसे डेटा मॉडल, लेकिन अपने प्रोग्राम में जो इंटरफेस है, आपका जो मॉड्यूल है बनाते हो वो सेम रहता है, और डेटाबेस चेंज कर देते हो.
करेक्ट. लिसनर चेंज कर दिया आपने,
वो हमेशा सेम रहता है.
सो लिसनर इज लाइक नेट. If you're using MySQL listener or an Oracle listener, so that is like NED. Okay, but your program is creating a data model that this is what I need to do, and then you are making a connection, you are defining an object called connection, and then you are calling the listener, and then you are passing the query.
बेसिकली ये मॉडल ये कर रहा है कि लाइक कितने भी डिवाइसेस हैं, बट उसके जो हमारे फील्ड्स हैं वो कॉमन स्ट्रक्चर कर दिए.
वो कॉमन स्ट्रक्चर कर दिए हैं. तो अब जब यूजर को देना है ना, तो यूजर को बहुत अलग अलग फॉर्मेट में हर डिवाइस को कुछ नहीं देना. यूजर को सिर्फ एक जगह पे यांग मॉडल को यूजर इनपुट्स फीड करना है. एक बार user inputs feed हो गए, then rest of the magic will be done within the NSO using the YANG and the template, and it will be pushed to the device using that.
सर इसी YANG मॉडल को यूज करके वो मतलब एक फॉर्म फील्ड बनाता है ना, जैसे कि
Correct.
IP एड्रेस.
Correct. तो अभी वो बनाएंगे. So we will create a YANG model, we will create a service, and we will call that service from the API also. Both JSON RPC as well as REST API. Postman say we can easily call that, and then you can import it in your BPA. You can do data inputs or user inputs from BPA, and that will work. Okay. So continuation of YANG module. So there is another of the data type called list. So list can have multiple leaves inside it. So list is a array kind of. It's not an array. It's a tree kind of thing where you have multiple leaves. So if you create a list called service or L2 VPN service or maybe loopback interface, then it can have multiple leaves. So here I have created a list loopback interface, and then I have to define a key to the list. So key will be something like a unique key or your key as in a database. So it will remain unique and it will be mandatory. Then I'm saying leaf loopback. So I'm defining the leaf within the list, and type is a string, and I'm saying uses IF data. So that means IF data is again a data type. Yes, IP address and mask, and that is defined in our imports, initial imports. Then notification, link failure. So notification is another this thing. This leaf is IF name is another leaf. Then IF admin status is another leaf, and their types are uint8 and string respectively. Then we have a leaf interface name. Then we have a leaf status. So leaf and list are two common data types which we are using. I'll only go with these 2-3 data types so that you are aware of these 2-3 data types, and we'll use this while we do the YANG model for our first YANG model, very small one for L2 VPN. So leaf, again, variable. Programming equivalent is variable. Description is contains a single value of a specific type. Leaf list is an array, kind of array. मतलब array नहीं होता, but array की तरह programming में if you want to have an equivalent or you want to equate it to something, so that will be array. Contains a list of values of same type. Then container is a kind of record. Contains a single structure containing 0 or more values or other statements, hierarchy. Then list is kind of an array of records. So array of leaves or maybe number of leaves, something like this. Contains a list of 0 or more set of values and other statement hierarchy.